Okay, in this video, we're going to explore using digital outputs with Egret. Uh, this is a pretty simple test. I have 24-volt LEDs attached to the Lite6, and I'm just going to turn on the output, turn on and off the output of the digital pins, and you can see the lights turn on and off. So I'll just go ahead and reset this back to the initial position. The initial position blocks the LED, so I'll just run this code and you'll see it run. And then we'll go over how we built this inside of Egret. So I turn on one LED, I turn on the second LED after 3 seconds, and that's the end of the code. But if I run this again, you'll see that I turn off all the LEDs in the beginning. So I'm just turning all the digital outputs out and restarting the program. You'll notice the machine is not moving at the moment because I'm already at my position. I throw some len commands in there, but I don't move it during the cycling of the LEDs. You could, definitely for sure, but I didn't. That's why you saw the first movement after the initial position, and then it goes to the initial len position. All right, let's go ahead and rebuild this script. I will give you the script at the end, but let's go ahead and just rebuild this from scratch. Actually, I'm going to delete. I want to keep this point. So I'm assuming you just opened a new canvas inside of Grasshopper. We can go to Egret and pick out your robot that you have, or you can use the robot node and select your robot you have there. I have the Lite6, and we're going to throw in our stage. Again, that's converting all the movement commands, digital commands, weight command, everything into a workable code for our robot. It's also checking for collisions and things like that. So let's go ahead and now add a len movement. Again, the len movement takes a point or a plane. I'm going to feed it a point. I am going to get an error here. Let's switch this to the real view of the robot. Cool. You see we get a singularity issue. Yeah. Why is this? Because you can see the Z is facing up in the Z positive direction and our effector is facing down. So the robot is going to try approaching it from the underneath. It's a quick fix. We can just flip the plane. And now our robot goes to that point. We'll go ahead and output this code. We'll use Python and G code just to show functionality of both. Oops, wrong one. G code. Perfect. We can attach some panels to it just to see the output. We'll also throw a panel here. And that is the G code output. As you can see, it's much simpler to the Python one, but it's whatever you prefer to use. So right now, this code is only going to go to that position, whatever this point is. In my case, it's 300, negative 100, 200. So let's go ahead and send multiple commands to the stage. Let's go ahead and do merge. And now we can start staging multiple commands into the motion. Let's go ahead and just add our digital output. We'll go utilities, and then we'll go to digital output. You do see we have an analog output, but we're going to use digital. You can see in P, it stands for pen. we can say what pin number we want to use. By default, we start at 0. And we'll go ahead and drag it into the merge command there. So what is this output? It's saying digital output is 1. What is 1? Well, we can toggle on or off. So if it's 1, it's high, meaning it's open. So in my case, it's going to turn the LED on. I should note that my LEDs share a common 24 volt. I bought 24 volt LEDs. Most LEDs are like 5 volt, so just be aware that you'll need to put a resistor on if you're using a LED, or get 24 volt LEDs, or maybe whatever your load is. Maybe you're talking to a PLC, it accepts 24 volt. But anyways, I open the digital pens, so it's grounding. So I'm completing the circuit by opening up that pen. So you can see, let me make this a little bit better. We're going to set the arm, it's going to move to that position, and then we're going to turn the digital pen 0 high. So that would work. I mean, if we want to do another pen, we can either make this a list, like put multiple integers in there, or we can just cut and paste this again and add it to a second command, change that to 1. Maybe we can do 3. And add it. You can see it starts adding to the code. We're just indexing up 1 each time, and we're setting them to high. Well, maybe when we first start the program, we want to make sure they're all off. Maybe that's what your cell or your setup looks like. So we can just take another one of these components, drag it into the beginning of the program, and we can set to low. You can see right in the beginning, both up here and there, that we're setting pen 2 to 0. So it's going to turn the pen low. We can set all of them. We can just do 0, 1, 2. And you can see over here, it's going to turn off in the very beginning, pen 1, 2, and 3, or technically 0, 1, 2, low. So right when we start the program, it's going to just turn off all the pens to 0, and then it will go to this lin position and then turn on these 3 outputs, these 3 pens high. We could bring it a little bit further and put wait commands in between. So if you go to utilities, you can go to wait, define we can do 1 second. And we can just add a 1 second interval in between each LED turning on. So you can see you can do a time sleep of 1 second in between each. So it'll be like first LED, second LED, third LED. And that's the end of the program. I'm sure there's more of an elegant way you could use intertwine, and so you could just add a series component to this. So if we could pre-populate this through 1 through 5 or 7, whatever numbers of outputs you have, and you can use some fancy tools to kind of cut down on the spaghetti mess. But yeah, that's how that code works. One tool I haven't shown yet is, sure, we can copy this code, bring it over, paste it. But we could also just save this output, the code. So you would drag the output of either the G code or the Python code, and we would have to give it a path. I'll just give it to, I think I have this as a path. And then we also have to tell it the file name, so we'll just make it test.txt. It's only going to save when it's a bool of true. I'll just make a button. And I'm going to turn on overwrite. So if I already have test.txt, it's not going to replace it unless I make this true. Oops, always do that. True. I'll press the button. You can see it just wrote 1147. That is the correct file. And of course, we can open it, and it's a text document. And we can load it into UFactory UI from there, or cut and paste it, whatever you choose. So that is how you use the digital outputs. Likewise, it's the same for the analog. You just replace output or the digital outputs with analog. Cool. So I'm going to stop the video here, and we'll make some more videos.